Let's solve the first question. So in case if you have missed the concept, I'll just quickly revise the concept for all of you and then we'll solve the question. Please see the concept. See here. Let's say you have a single charge, or you can have a system of charge. You can have a single charge. Let's say you are given with a single charge or a system of charge charges. This is what is given to you. So you have this. Done. Now your point here. So at this point, let's say you have placed some other charge here, let's say Q, and this charge is moved from here to here. This was your initial position and this was your final position. So you have a charge here, a single charge, or it can be a system of charge, and then in the surrounding of these charges, you have kept a charge, and the charge is moved from one position to another position. So with respect to this, you have a general concept. I'll discuss the general concept for all of you. That is delta V. At this point, all the charges will have some potential here, and here also you will have some. So the potential difference between these 2 points, let's say, is dV. This potential is due to the potential. At this point, you will have some potential here, and at this point, you will have some. Let's say potential here is V, and here the potential is V plus dV. This potential, what you're writing at these 2 points is due to these charges. So now we have a relation here. Delta V, this delta dV is always defined as du. You will have a small change in electric potential energy. Obviously, this charge and this charge which you are moving will have some potential energy with respect to this configuration, and then with respect to this configuration, right? So we'll have some change in potential energy also. Du divided by charge that you have moved, that is Q, is always given as minus of a small work done by electric force. Electric force divided charge that you have moved, it's a Q, is also equals to dW by agent, external agent divided charge that you have moved, and this is also equals to a relationship you have here, that is minus of E vector dot dr vector. This is what you have. So all the questions which we are going to discuss. Okay, so now you have seen this also. We have done a small derivation also. That is, if they give you a small charge, let's say plus Q charge, and they ask you what is the potential here at distance of r from it. So the value of V you write is what? K Q by R. Now this Q can be positive or negative, anything. So you'll see all the questions based on these concepts. If you want, you can take a screenshot. So whether you're studying this concept for boards or for JEE, anywhere, this is much you should know regarding potential. Again, I will brief this concept to all of us here. You will be given with a charge or a system. Okay, how you define a potential? See, I'll just explain the basic definition of potential first. See, let's say if I ask you, let's say you have a how you define a potential at any point. It is defined like this. You move a charge from infinity, let's say from infinity, slowly to this point in a quasi-static manner. What's the meaning of quasi-static manner? It is infinitesimally slow motion. If you move the charge like this, then in that case, whatever work is done by the agent divided by charge itself. Whatever is work done by external agent in moving this charge q from where? From infinity to this location of r divided by q. This is called as what? Potential at point q. This is how we define it. This is very, very important. See, I'll give you a logic. Let's say right now, so we are discussing only this. When I'll teach you for J, second level of J, then I'll teach you this. See, let's say I will give you a solid sphere like this, or let's say I give you this. Let's say you have a spherical shell. You have a spherical shell there. Why I'm giving this example? Just to make you understand the exact meaning of potential. So let's say you have a spherical shell here. Diagram is not coming properly. Okay, so let's say you have a spherical shell here. Now you have given some energy to this. So you have placed some charge to this. Let's say you have placed some charge here. Plus Q. So if I ask you, what is the self energy of this spherical charge system? Now, what is the meaning of self energy here? See, you know this concept, right? Whenever I keep two charges, Q1 and Q2 and Q2 at a separation of R. So what happens? I can imagine like this. I can imagine that this is fixed, or you can say that initially these two charges were at infinite separation, and from there you have moved them slowly, and now the final separation is R. Total work done by the agent in changing this configuration from where? Infinite separation to separation of R. Whatever work is done by the external agent is called as potential energy in this configuration, and then we write U equals to what? We write U equals to K Q1 into Q2 by R. This is how we have defined the electric potential energy of a two-charge system. Here also you can see that you will have infinite such two-charge system. You can take this one pair like this. You have infinite pairs of charges, right? So obviously there will be also some energy in this configuration, the way you have here. So how to calculate the energy in this configuration? Again, very, very important concept. You will see some good questions in G. Let's give you an idea. Let's see how we calculate this. See, what we'll do. Let's say at any moment, we'll believe that the charge on this is plus Q. So at this stage, if I ask you what is the potential of this spherical surface, you know that at this point, if I ask you what is the potential here, the formula is K Q by R. This is the formula of V at this moment. Now, how we get this formula? This can be obtained by a very simple integration. Wait a second. Yeah, then I will go to integration only. So what's the point? Then the very detailed discussion in that case. Okay, let's restrict ourselves to only this much at this moment. See, what I'm telling you at this moment is रुको यार एक अच्छे से बता ही देता हूँ. See here. See here. The first concept that you have here is concept of electric listen. First concept that you have is your electric potential energy concept. Electric potential energy concept. Energy of a two charge system, of a two charge system. This is what this is the first topic that you have. So let me discuss this first and then we'll proceed further. So I'll just complete the concept first, then we'll go to the questions. Okay, so how we have discussed this concept? See here. Let's say you have a charge here, Q1, and then you have another charge here, Q2. So obviously, let's say if they both have same sign, means what? Both are positive or both are negative. In that case, if you place them at a separation of R, you have to keep them, you have to hold these charges. Why? Because they'll repelling each other, right? The moment you leave, they will fly apart. And the moment if you bring them more close, what will happen? And then you leave, you'll see more energy into the system the moment you leave them. Means what? There is some energy which you can always see with which changes when you change the configuration of these two charge system, that is R. The energy that depends upon configuration of any system of particles is called the potential energy. Since here the system of particles is charged particle system, then you call this energy as what? Electric potential energy. But then how we define the energy here are? We'll go to work energy theorem. So the definition comes from work energy theorem. What is work energy theorem? Work energy theorem is work done by all forces is equals to what? Change in kinetic energy. This is what we have work energy theorem. So work done by all forces means what? Work done by conservative force, work done by non-conservative force plus work done by applied force is equals to what? Change in kinetic energy. You know that electric force is a conservative force. Electric force is a conservative force. So now if I bring this, let's say I fix this and then I move Q2. Let's say I move Q2 from infinity. From where? From infinity. Let's say is infinity. And I'm bringing this slowly to this. You know that for a conservative force, work done is path independent. And therefore for electric force also work done will be path independent. And therefore we can take the straight path. So bringing the charge, let's say Q1 is fixed and Q2 we are moving from where? Infinity to this location in a quasi-static manner. In a quasi-static manner. Now why we take quasi-static only? Then only this delta K will be 0. There's no applied force. This can be straight away written as 0. Sorry. Second applied force there. Obviously we have to apply, then only it will move. Working by applied force, so this is there. But this is 0. There's no non-conservative force. And work done by conservative force, electric force, because electric force will continuously act. The moment this charge enters into the field of this, so you'll have some electric force. The electric force will apply some work, and this field will also do work against it. Then only this is possible to move it slowly, right? So what will happen? This is nothing but minus of delta U. What will see from here? Delta U will come out to what? Delta U will come out to be work done by applied force during this process. This is what you have here. So how will calculate work done by applied forces? See, we'll take any intermediate separation. Let's say this. Let's say from here to here, we take this distance as x. So we'll have force acting on F. How much force will act? Let's say both are positive. We are considering both as positive. So electric force will in this direction. This is F electric. F electric. And what is the value of F electric here? your F electric will be equals to F electric will be equals to 1 by 4 pi epsilon naught Q1 into Q2 upon what? R. This is R square. This is the force that you will have, Coulomb force. So how much force the agent has to apply in order to move it in a quasi-static manner? The same force agent will apply in this direction. In this direction, F by agent in the opposite direction. So if the particle, if this Q moves by a small distance, let's say dr, from this point, dr, or let's say dr, yeah, dr. So this force by agent can be taken as constant. So small work done by agent, therefore small work done by agent will be given as what? Force. That is your 1 by 4 pi epsilon naught Q1 into Q2. I may take slightly longer time to complete this topic, but trust me, I'll try to teach you a very refined format of these concepts, which will help you everywhere. 1 by 4 pi epsilon naught Q1 Q2 by R square into what? Into you let dr into cos 0, because both are in the same direction, so cos 0 degree. Cos 0 degree is what? 1. So you'll get dw by agent. So if your total work done will be what? Total work done by agent. Total work done by agent, if you want to calculate, this will come out to what? This will come out to be integration of this 1 by 4 pi epsilon naught, you will write as it is. Q1 Q2 is constant outside. Integration of what? R to the power minus 2 into dr. From where to where? From infinity to R. Now what is the integration of R to the power minus 2? R to the power minus 2 plus 1 by minus 2 plus 1. So we'll get here, we will get here Q1 Q2 by 4 pi epsilon naught. You will get here minus 1 by R. From where to where? From infinity till R. So when you put in R, you will get R only. When you put infinity, 1 by infinity is 0. So what is the final answer you will get here? Q1 into Q2 by 4 pi epsilon naught into R. You got the formula. Therefore, delta U, that is U at R minus U at infinity, came out to what? Came out to be Q1 into Q2 by 4 pi epsilon naught into R. If I take U at infinity to be 0, obviously we can take this, we can have this choice. The reason is, if you keep two charges at a very infinite separation and then you leave them, what will happen? They will neither attract nor repel, right? So we can take U at infinity to be 0. Therefore, U at R, we can take as what? U at R can be taken as 1 by 4 pi epsilon is basically K, electrostatic force constant, into what? Q1 into Q2 by what? R. This is what you have. But then now you know what is the meaning of this energy here. This is basically work done by external agent in forming this configuration Q1, Q2 at separation of R from infinite separation. Right? Now always remember, substitute Q1, Q2 with sign. Substitute Q1 and Q2 with sign here. With sign. So if we have, and one last consideration for n charge system, for if we have for n point charge system, if I ask you calculate the total energy of this total electric potential energy configuration, so you will see how many pairs you will have. NC2, because if you have n charges, NC2, for every one pair you will get one energy. NC2 will come out to what? N into n minus 1 by 2. Example, if I give you 4, n is 4. With this you can have a square, you can have rectangle with 4 vertices, right? You can have a square, you can have a rectangle, right? You can have any quadrilateral, but then with any quadrilateral it's very difficult to apply geometry. So normally you will be given with a square or a rectangle. So when you put 4 here, 4. So 4 minus of 3 by 2, so throw into this, you will get 6. Therefore 6 pairs will get 6 pairs we will have. How 6 pairs you will have? You can see from here. If I take this, you have charges, so this will, you have 4 charges here. So one pair you can form like this: 1 pair, 2, 3, 4, 5, and then 6. You'll get 6 pairs. So for each you will apply this formula K Q1 Q2 by R, and you will add all. That will give you the energy of this configuration. Means what? This much energy is spent by the external agent in forming this configuration. From where? From infinity to this configuration. Let's say, I'm just giving example. Let's say example, this configuration, the energy comes out to plus 50 joule. I'm giving example. Let's say the energy, total energy comes out to 50 joule. An obvious question that is asked is how much energy now you need to supply to this configuration so that they will go to infinite separation again. Answer will be what? Minus 50 joule. Because at infinite separation, total energy has to be zero. So if you're getting the energy, this configuration is plus 50 joule. So you have to supply minus 50 joule from outside. Then only all the charge particle will go to infinite separation. Okay. This completes the concept of electric potential energy. If you want, you can take the screenshot here. Okay. If anyone is having doubt anywhere in these concepts, please ask here. किसी को कुछ डाउट है तो प्लीज पूछ लो. Feel free to ask here. Please don't hesitate to ask anything. If you have any doubt here, please ask. Now I tried to answer here that why it should be quasi-static, because then only delta K will be zero. There is no non-conservative force. There is only conservative force. What is that? Electric force. Because when the charge will move under the field of Q1. Right. So Q1 will always create a field. That field will exert force on Q2. So Q2 is moving only under the action of conservative force. If you want this to be zero, there has to be something which will cancel this, right? This is applied force. So we will also do work. How much work will do? Exactly what is done by the conservative force. So that both will cancel, but the sign will be opposite. You can see from here. Like in this case, if we consider both Q1 and Q2 to be same sign, what is happening here? The force, electric force, and the agent force both are in opposite direction. So work done by electric force and work done by agent will be in opposite direction. So both will have different sign. They can cancel out and they can give you zero at the end. Actually, we know from work energy theorem, work power energy, that work done by conservative force is always minus delta U. So delta U in this case for this system of two charges will be equal to what? Work done by external agent. So I bring the charge from infinity to this configuration. I want to calculate the work done by external agent. So that I took any intermediate position here, x. So at that point, I am just writing the force due to this charge, and then agent will apply same force in the opposite direction. Then only this kinetic energy V will not change, and then we'll get this. So work done by small agent for work done by agent, small work done by agent for a dr displacement we can apply, and then we integrate that from infinity to r. So we get it. This is itself is given as what you are. So you infinity can be taken as zero. So this is all good. For numerical solving, you should always know this concept at NC2. If you are given with n system of charges, so NC2 will give you the number of pairs. For each pair, you apply this KQ1, Q2 by R and add all of them. That will give you the total energy. Let's say this energy comes from 50 joules. So how much energy you need to supply in order to make this charge go to infinite separation? Answer will be minus 50 joule. Okay. Now let's see the concept of potential. Now electric potential. To make this discussion very easy, we'll start with the electric potential concept with respect to a single point charge. And later, we can extend this concept for any system of charges. Let's see. First of all, we'll study this concept with reference to a single positive charge. Or single point charge, sorry, single point charge. Let's see here. Let's say you are given with a single point charge. Let's say plus Q. And you want to study at distance of r, we want to study what is the electric potential value, V. What is the value V? So how will we get the value this? How we define this value here? See, what we do in this case, we'll bring a charge Q from where? From infinity in a quasi-static manner to this point, So obviously, when you say quasi-static, when you say quasi-static, definitely the agent is also doing work, because this will definitely have force due to this. Net force has to be zero. So whatever work you do, whatever the external agent will do work in order to transfer it from here to here, that work done. So potential at this point, let's say potential is V. This V we define as what? This V, what we have written here, this V. This V is defined as electric potential at P. Let's say point is P. Electric potential at P is defined as, let's say V, work done by external agent to move the charge Q from where? From to move the charge Q from agent to move Q from infinity external agent to move Q from infinity to P divided by Q. This is what we have. But this should be what? Quasi-static. This should be quasi-static. Quasi-static. This is what we have. Now, just now we have seen it. Just now we have seen this work done by comes out to what? When you have it comes out to be K capital Q into Q divided by R. And then you divide by Q. So Q will cancel. So answer will comes out to what? V comes out to be K into Q by R. Straight away you get the answer like this. So two things straight away you can understand from here. First, if they give you multiple charges like this, let's say if they give you multiple points, let's say Q1, Q2, like this, Q3, like this, they give you multiple charges, let's say Qn. And then they ask you, they give you a point P, they ask you what is Vp? What is Vp? Vp equals to what? So what you can do, you can calculate the potential, electric potential to all charges individually, and you can add them, right? So what the answer will get here? K Q1 by R1 plus K Q2 by R2 up to this, up to K Qn by Rn. This is first concept. Second concept, very important concept. Let's see this. I'll give you some scenarios there. See, let's say you have a square. Let's say you have a square like this. And then they ask you, and then they give you first, it's a square. They give you, let's say, 4 charges like this. They give you here Q1, Q2, Q3, Q4. They give you like this. And then they ask you, what is the potential at the center? So you can see that all this will be what? At equidistant, right? All this point will be equidistant from the 4 location of the charges. Let's say R, 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 R. The side is A. The side is A. You can see that R will be what? R will be root 2A by 2. Therefore, if we apply this formula, in all the cases, R will be same. R1, R2, R3, R will be same. Therefore, you will get V equals to what? V at O. Let's say this point is O. V at O will be what? This K by R will come outside. And what will get here? You will get Q1 plus Q2 plus Q3 plus Q4. That is your Q net. So K Q net by R. So here only you can write a special case. What is special case? If R1 is equals to R2 up to Rn, all are equals to R, let's say, then V of P can be written as what? V of P can be written as K Q net by R. And one of the very common application of this in terms, let's say they give you a ring of charge. Let's say they give you a ring of charge like this. Let's say plus, plus, plus. So all the charges are spread over the circumference like this, plus, plus, plus like this. Okay, and now from this axial point, from this at a point from this on this axial point, they'll give you a point. Let's say they'll give you some point here. Let's say this point is your P. A radius is given to be R. This is your X, and they ask total charge is Q. Let's say total charge is plus Q. They charge you what is the potential at P. So how will calculate it? See, it's very easy. What you can do here is you can take elementary charge here. Let's say dq. I take an elementary charge here dq. Now if you join from here, this will be nothing but slant height of the cone. Slant height of the cone. What is the value of this? You can use Pythagoras theorem. You will get root of r square plus x square. Now can you see? If I take any dq, all dq will have the same distance from this p, because all will be at distance of slant height, right? So what is the formula of vp? Vp will come out to what? Vp will come out to be k q net. Q net is what? Total charge. Q by what? R. What is R? Root of r square plus x square. If you want, you can take the screenshot here of these many concepts. And the last concept I discussed now after this. Anyone is here, you can ask here. See, what I've discussed at this point is how you work out with cases of single point charge. And then I have taken those system of point charges for which the point where you have to calculate the potential, that point is equidistant from all the different what you call point charges that is forming a system of charges, whether here or here. In such cases, straight away you can apply the formula k q unit by r. Why? Because r1, r2, r3, everything will be same, right? So you can take that common. What will get? K by r, q1 plus q2 plus q1. So k q unit by r. This is what we have used here in the ring of charge also. This is what we use here also. If anyone is having doubt in these concepts, please ask them. Now we'll take this concept to a differential format. Now we'll convert this concept into a differential format, and then at the end I'll teach you what is the concept self energy, and then we'll start solving the numerical set. Now let's convert this electric potential concept into differential format. Let's see here. Electric potential concept in differential form. In differential form. Let's try to understand this concept. Okay, please hear. See, let's say the same charge. Let's say you have plus q here. Now I'll move a charge q from a position to next position, which are very, very near. Let's say dr. Let's say dr. Dr. It is moved from here to here. So from here to here, let us change. Let's the potential here was v. The potential here was v, and the potential is v plus dv. So how we are changing potential? Changing potential is this minus this, no? That is dv equals to what? Change in electric potential energy, that is du divided by the charge that you have moved. But what is du? D is nothing but the work done by external agent divided by q equals to what? Minus of work done by electric field by q. And now why it is minus of E dot dr vector? Let's try to understand this here. See, let's say this will create field here. Let's say at that point, at this point, let's say you have some field E vector, and the charge that you have placed at point P, let's say this point is P or whatever, let's say the charge is Q. So due to this, it will experience a force. This charge will experience a force, QE vector. Notice it will move. Let's say it moves by displacement dr vector. Sine is theta. So what is the work done by the field? This dw. Therefore, what will let dv equals to what? Will let dv equals to minus of dw by field force divided by the charge that you have moved q. So what is this? This will be your minus of QE vector is the force by the electric field, not dr vector divided by q. So what will happen? Q will cancel, and hence you will get dv equals to what? And hence you will get dv equals to minus of E dot dr vector. Now this relation is a very important relation here. See, you can see something very important from here. At this point, electric field is E vector, and then you have moved in a direction at an angle theta with E vector. This is your dr vector. Dr vector. So you can see from here that doing this movement dr, what is dv? dv is given as minus of E vector dot dr vector. Now the first thing that you can see from here is if theta is 90 degree, E dot dr will be 0. Means what? dv will be 0. dv will be 0. That is v is constant. So what is the conclusion from here? If we move in a direction perpendicular to electric field, your potential will never change. If we move in a direction perpendicular to electric field, your potential will never change. V will be constant. I'll give you an example. Let's see. You just enjoy this concept. Let's see here. I'll take the case of electric dipole. You have here minus q, and here you have plus q. What you have derived in class 12 NCRT syllabus is this. If I ask you what is the electric field here, electric field comes out to be perpendicular like this to this. It comes like this. At any point, if I ask you electric field is like this, at any point electric field is like this, at any point electric field is like this, at any point electric field is like this. So if I start moving in this direction, what will happen? Your V will be always constant. I know this V is what? Actually 0. That we can easily understand why V is 0, but it will be constant. That we can understand from here also, because everywhere electric field we are moving this equatorial line, equatorial line, at every point what will happen? Actually we are moving perpendicular to electric field direction, so V should never change, and that constant value is 0. How it is 0? You can see from here. If I take any point, let's say at this point, if I ask what is the potential, it will join from here. Will join from here. So what will happen? So what will happen? This will be R. This will be also R. Both the distance will be same now. So what is the potential here? You will let, for this you will let K into minus Q by R, and for this you will let what? Plus K into Q by R. See 0 over. But why it is like constant, that can also be understood. This way also you can prove it mathematically, right? But then if you want to use this relation, that this also helps you that okay, you're moving normal to it, and therefore it's constant. Next application, see here. Next application. Again, I'll draw the same diagram. At this point, we had this E vector, and we moved dr vector, which makes an angle theta with E vector. So if I just open this dot product, what will get? You will get from here to here. We're writing dv, na? We're writing dv. So what dv? Therefore, dv you can write as what? You can write as minus of E into dr into cos theta. So from here, can you see very interesting thing here? If okay, first of all, can you see here E cos theta equals to what? E cos theta will be equals to minus of dv upon dr. अक्षांश हो गया तुम अभी यहाँ पे Akshans, are you there in the class at this moment?
Yes, sir.
हाँ, तो आपने डाउट पूछा था अक्षांश, आपका आंसर अभी आ रहा है। आप जो SC1 से पढ़ रहे थे, SC1 से आपको नहीं समझ में आया था, अच्छे सुनना, आपका अभी डाउट क्लियर हो जाएगा. Okay, please hear. So E cos theta will be equal to what? E cos theta will be equal to dV by dr minus dV by dr. Now what is E cos theta here? See here, what is E cos theta? If I see this E vector here, I can resolve this E vector into two components. One this side, one in this direction, and one perpendicular to it. So E parallel. E parallel is what? E parallel is basically E cos theta. Na? Your E parallel component is basically what? E cos theta. This what you see here is basically your E parallel. Therefore, from here, what you see? E parallel. Parallel means what? If you're moving along dr and you want the component of electric field along your movement, that is always given as what? Minus dV by dr. E parallel is always given as minus of dV by dr. Now, what you can see from here is what happens if theta is 0 degree? Means what? You have started moving along the direction of the electric field only. By the way, this movement 90 degree and this movement 0 degree covers all cases of what you call movements, because any movement you can resolve two components, right? One along the electric field direction and one perpendicular to it, and therefore it will cover all the possible directions. So let's see what will happen with 0 degree case here. Please here, what will happen with 0 degree? This will become E cos 0. Will become this cos theta will be maximum, so you will get E max. You get E max equals to what? Minus of dV by dr. It is what? Maximum positive value. It is what? Maximum positive value. Maximum positive value. So what happens? This dV by dr will be what? Maximum negative. This will be what? Maximum negative. Maximum negative. Then negative will become positive. Then what you can conclude, and what you can conclude from here? What is the conclusion from here? Electric field always acts in direction of maximum decreasing potential. Maximum decreasing potential. Because you have taken the case of 0 degree. 0 degree means what? You are moving along the direction of the electric field. So obviously, when you move along the direction of the electric field, what do you find from here? This becomes maximum. Maximum positive means what? This dV by dr is maximum negative. Then only you get maximum positive, no? And therefore, what is our conclusion? We say that electric field always acts in direction of maximum decreasing potential. Now, after this, one formula should always keep in mind here. That is, acha, let's say from here you can also understand a very important concept, that is E parallel is this, no? So let's say if they give you V, electric potential, as a function of X, Y, and Z. Let's say they give you a very, very common question here in paper. If they give you V as a function of X, Y, and Z. Again, a small what you call thing, Alex, I will tell you. If the students who have taken medical and they feel like these concepts are not asked in Neet, you'll see these questions. So just wait for some more time. You'll see how many questions they have asked in Neet. In fact, they have asked slightly better questions with the concept of this differential in Neet than JEE Main. You will see that in this sheet only. So from here, if I ask you to write the electric field, how you write electric field? Therefore, electric field you will write as what? Electric field you will write as Ex I cap plus Ey j cap plus Ez k cap. Now in this case, how we get Ex? So I'll differentiate V only, but partially, because our movement is along the x-axis right now. So what I will write here? I will write a minus of dou V by dou X. I'll tell you what's the meaning of dou V by dou X times of I cap. And then how will get my Ey component? Dou V by dou Y times j cap. And then how will get Z component? Minus of dou V by dou Z times of k cap. Means what? I will differentiate the v function partially with respect to x. When we say partially, when differentiating v, I will keep only x as variable. I'll treat y and z as constant. When I'm calculating dou v by dou y, I'll keep only x and z as variable. Sorry, x only y as variable, x and z as constant. When I'm calculating dou v by dou z, I'll keep x and y as constant, only z as variable. That's the meaning of this. I'll teach you this concept with the help of a question. But this you can understand. I'm moving around the x-axis. I can use this concept. E parallel is given by dou v by dou r. Dou r is what? X है, so I will calculate dou v by dou x. This is what you have. अक्षर से समझ में आ रहा है कैसे लिख रहा हूँ अभी ये expression?
Yes, sir.
Okay. I'll show you like how we apply with the help of the question, but you should understand what I'm writing it. Now one more formula should always keep in mind. That is, एक और concept है लिख लो अच्छे से, समझ लो अच्छे से. That is this. This you'll use a lot. In 0 degree case only, you have a special. You just by heart this formula. Let's say this is electric field E vector, and let's say I'm moving from point number 1 to point number 2. This is given as D. This is given as D. So let's say I take this point 1 as origin. At any point I will take x, let's say x, and then I move by a small distance dx. So what is dv ulet? Dv ulet is what? Dv ulet is minus of e dx. Dot dx means what? Both are in the same direction. So we'll let e dx is e dx. And then when you integrate, minus of e ulet integrate dx from where to where? From 0 to d, 0 to d. It will get d. So v equals to what? Minus of ed. Now we have already used this. Where you have used? I will show you the application of this here. We have already used this in this case here. In case of parallel plate capacitor, you have already used this concept. This was your plus, everywhere plus, plus, plus. And there you have minus, 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 minus. The electric field was uniform. E vector was uniform. E vector was uniform. Sigma by epsilon, right? If it is D, straight away we write. See, electric field goes from where to where? Higher to potential, higher to lower potential, higher to lower potential, right? So you can see that. Sorry, it's V2 minus V1. Then sorry, this is V2 minus V1. Sorry, V2 minus V1 will get. Hai, this is V2 minus V1 because 0 to D. A second, I just see here. Here for this dx, we will let dv. What is dv? dv will be your minus of e dx. When I integrate this dv, let's say I'm putting 1 to 2, 1 to 2. So I'll let minus of e integration of dx from where to where? From 1 to 2. Means what? 0 to d, 0 to d. So I'll get v2 minus v1, v2 minus v1 as minus of ed. If I ask you to write v1 minus v2, the answer will be plus ed, obviously. It goes from higher to lower potential. That's why we write the potential as V plus, here the potential is V minus. And straight away we write what? V plus minus V minus equals to what? ED. And we solve the question in capacitor. This is the application that we have already seen. These many concepts you always keep in mind. That if you want, you can take the screenshot. Again, I'll brief you what I have discussed here slowly. Try to digest all these concepts here. Please here. You have a charge Q here. And now in its surrounding, I'm trying to create a differential form of electric potential. So what we do here, we take a charge Q here and we move the charge from this position to this position in a quasi-static manner. The potential due to this is V here and here is V plus dV. So what is dV? How we define dV? dV is du by Q. The dV is same as this and this is this, and then how you get this? You can see from here. If the charge is kept here, it will experience the force. What is the force? Q into E vector dot dr vector. This is a small work done by the electric force, and minus is there, definition here, and then QQ will cancel. Look at this relation. Now this relation is very, very important. Now you can explore this relation. You can always keep this diagram in mind. This is dr, this is dr, this is dr. So along this direction, what is dv? This is the dv value. You can see from here. If your theta is 0 degree, V will be constant. Whenever you move perpendicular to electric field, your potential will never change. Always keep this in mind. Whenever you move perpendicular to electric field, your potential will never change. You can see this example also. You know that on equatorial line, electric field is always like this. So when you're moving along this line, what will happen? Your potential will never change because you're always moving perpendicular to the electric field. By the way, mathematically also you can cross verify on this line what will happen at every point. This will create minus KQY, and you will get 0. Second, if you see from here, what is the component of electric field you have here? E cos theta. What is E cos theta? Minus of dou v by dv by dr. Means what is E cos theta? Component of electric field along your movement, Therefore, if they give you V as a function of x, y, and z, and they ask you calculate the electric field. So what you can do, you can at any point you can move some distance dx along the x-axis, then some distance along the dy, and some distance along the z-axis dz. So how will you get ex, ey, and z? Ax will be what? Minus of dou v by dou x. What does it mean? This I'm differentiating v by keeping only x as variable, other as constant. Then dou v by dou y. This will give you ey, and then dou v by dou z, and we add on, we'll get the total electric field expression. So whenever v is given to you, I can always use this to calculate the total electric field expression. And one more very important concept, that is when you see this, we have E cos theta. So when I take theta as 0 degree, means what? Theta as 0 degree means what? You are moving dr and E are parallel, means what? You are moving along the direction of the electric field only. So this becomes E maximum. There is no cos theta is always less than 1, right? So we are not multiplying E with any fraction. Means what? We are getting maximum on the left hand side. Positive, maximum positive. This will be maximum positive. Then so the dv by dr has to be maximum negative in that case. That's why we write what? Electric field always acts in direction of maximum decreasing potential. Now for 0 degree case, you have a formula which you can always keep in mind. That is, electric field is moving like this and moving along the direction of this. So this V1 minus V2, as the electric field goes from higher potential to lower potential. So when I write V2 minus V1, it will be always negative. The answer comes out to minus ET. And if I write V1 minus V2, it will be always plus ET. This we have already applied in case of what? Parallel plate capacitor. Yes, if anyone is having doubt here, please ask him. किसी को इसमें डाउट है प्लीज पूछ लो, कोई पॉइंट पे डाउट है प्लीज पूछ लो. किसी को डाउट है कहीं पे प्लीज पूछ लो इसमें. Yes, you can take the screenshot. Okay. Now let's see next. Yes, I just remove this now. The last thing, last concept, last set of concepts that you have. Some application. This is a very common application and very important also. dv is minus of E vector dot dr vector. Therefore, you can see from here that whenever electric field is 0, what will happen? Your dv will always be 0, and therefore v will be constant. This is the case of inside a conductor. Inside a conductor, your electric field is always 0. Therefore, if you take a conductor case, if you have a conductor here, what will happen? Your electric field is always 0, and therefore v will be constant. That's why in case of spherical shell, in case of spherical cell, what we do? This is what we have. If we give any charge to this, the charge resides only on the outer surface. It resides like this. This is your plus Q. You can see the electric field is 0 inside. So whatever the potential you have on the surface, the same potential you will write throughout. And then, so by the way, we know this. What we know? How we prove that the potential? See, we know that we already studied this concept. For outside point, the entire charge can be taken as a point charge kept at the center. So if I ask you what is the potential at distance of r, which r is outside, straight away the answer will be what? Straight away the answer will be kq by small r. This is valid till this point. So at this point also, if I ask what is the potential, answer will be kq by capital R. And inside, what will happen if I ask you anywhere inside? Answer will be what? At any point inside, v will be constant. V will be let's say this I call as this is your, let's say, surface Vs. So when V in is always equals to V in is always equals to Vs, and therefore if you draw the diagram, how you get the diagram? You get the diagram like this. Till you have reached the surface, this potential value will always be constant, and from here it will be inversely proportional like this. So V is inversely proportional to R, and here V is what? Constant. What is the value of V? KQ by capital R. This is your origin, this is your V, this is your R. Now, the last concept. This is the last concept. KQ by R, sorry, this is R. Calculation of work done or energy. Calculation of work done or energy. Energies of a system. Energy of a system using concept of potential. Using concept of potential. This is the last concept. And then we'll solve the questions. After studying all these concepts, and if you have actually gone through, if you have actually followed these concepts, you'll see the questions there. Trust me, they will joke in front of you, provided you know all these concepts and you have already actually understood these concepts. See here. Let's say you have a charge here. Charge or system of charge. Now I will go to the last part, that is you. So yeah, if you have a single charge, or you have a system of charge, then just write a charge system. You have some charge system. The system can be a single charge or a group of charge. So you have some charge system. You have some charge system here. So you have a charge system here. Now you have a charge Q which is moving from this point to this point. So if I ask you to calculate the work done during this movement, what you can do here, we have this formula, na? dV equals to what? dV is equals to what? dW by agent divided by what? Divided by Q. I just write here Q moving. So what is the formula I'll get? dW is always given by Q moving, whatever charge moving, into what? dV. Q moving into dV. So I'll just calculate the change in potential, multiply by the Q moving, you will get the work done by agent. It's very, very important formula. Now let's see. And if I ask you what is du, this itself is du, no? This itself is what? du. What is du then? Du can also be written as what? Let's say I'm moving a very small charge dq. I can write dq. Okay. Or let's say same concept. I'll just write it here. This dw is what? dw agent itself is du. What du then? Du will be your q moving into dv. Let's see this. Let's apply this concept for this case here. Let's see, have a spherical shell here. Let's see, have a spherical shell of charge. We have a spherical shell of charge. You have given charge like this, plus everywhere, like this. If I ask you what is the energy of this, I'm asking you what is the answer for electric potential energy for this spherical charge. This is the question. This I'll explain you, and I'll give you a small homework. Whoever wants can solve this here and can send me the solution for this. I will just definitely check that. See, the whole homework will do this. Now I will change the system to solid spherical charge. I'll change this to what? Solid spherical charge like this. I'll change this to solid spherical charge like this. It is a solid spherical charge. Solid spherical charge. Spherical charge. And then I'm asking what is the energy for this? Two questions here. This I will answer now, and this I'll give you a question. So whatever the way I'm deriving this expression, the similar ways you can derive this also. By the way, I will write the formula for both. This you should always know. By the way, the energy for this U will come out to be the value of this is your Q. If the total charge is Q, and radius is let's say capital R, the total energy will be your Q square by 8 pi epsilon naught into R. And here same thing. The total charge is let's say plus Q, radius is R. In this case, the energy U will come out to be 3 Q square by 20 pi epsilon naught into R. Let's see how we get this result. I'll explain you for this case. This is very simple. It's very, very easy. Please hear. What I'll do, I'll not consider Q in the beginning. I'll consider Q at any stage. Let's say the charge that you have on this spherical cell is Q. So what is the potential on this surface? V value will be what? V will be, just now we have seen on surface KQ by R. So I will enter K, that is 1 by 4 pi epsilon naught, Q by capital R. Now if I add dq over it, in that case, what is the work done you will get? What is the work done? V dq we can apply. V into dw, potential difference, into what? dq. Now what will happen? This is basically when we write V now. V is basically potential difference, not exactly V. It's a potential with respect to infinity. So potential will not change. This potential you can say it's almost constant. But dq, we will write a small work done equals to what? A small work done we will write as what? This is V into dq. V into dq. So we can write from here the V value into dq. So what will get here? We will get here 1 by 4 pi epsilon naught. We will get here Q into dq. So what total work done? Total work done from where to where? From 0 to capital Q now. So we can write from here 1 by 4 pi epsilon naught. What will happen? You will get here Q dq. Multiply from where to where? 0 to capital Q. Q square by 2 will get. Hence you will get Q square by 8 pi epsilon naught into R. R is also there. KQ by R. And you will get answer 8 pi epsilon naught into R. And this result you will get. If you want, you can take the screenshot here. So this is what here. This completes everything which you have in your syllabus for electric potential energy and electric potential. I've covered everything in detail because I know this is a slightly confusing topic here, but I tried my level best to teach this in 3 stages. You can always go through the same video. It's like only 1 hour video here. You'll get all the concepts. I'll just discuss this last part again. See it. Now what I'm teaching here is, let's say you are given with a system of charge and a charge is moving from one point to another point. So we can always use the potential concept to calculate the work done during this motion. Or we can use this. See, what we'll do here. We know this, dV is what? dV is given as dw by q, moving q. Right? This is what here. So now, what is dw? dw is also given as q into dv. Q into dv. So now, what we'll calculate the potential here, difference of these two, and multiply charge movement, we'll get the work done. We'll see some questions here. GW is also du, no? So like let's say in this case, let's say we have here a system of charge which is spread over a spherical surface, and now we want the energy of this. So at any instant, let's say the charge here is Q. So what is V? You will add V will add is what? KQ by R. You will add like this. Now if we add one more dq, so V will remain almost same. So we can add dw because of V dq. V dq. What's the value of V? Integrate from 0 to capital V, we'll get Q square by 8 pi epsilon into 1. This is what you have. Okay. Now let's solve questions to revise all these concepts. I'll discuss all the questions one by one. Let's solve the easy one first, and then we'll go to the. चलो कुछ easy solve कर लेते हैं पहले. ये तो कल ही solve किया था हम लोगों ने, अभी just solve किया, right? What is the answer? Answer is your spherical cell, right? Answer is your. So this we solved last class also. There's nothing in this. Okay, give me the answer for this question. A very fresh question of Neet 2020. Yeah. Give me the answer for this question fast. In a certain region of space with volume 0.2 meter cube, okay, some volume is given to you. The electric potential is found to be 5 volt throughout. The magnitude of electric field in this region is, what is the answer? Fast. सब दोस्त का आंसर, इसमें तो कुछ हाथ भी नहीं उठाना है, सीधा आंसर बोलना है इसका तो. Okay, answers are coming here. So we got one answer here. Wait a second here. A second. We are getting, okay, so 0. Okay, option number 2. Okay, so few students have answered 0. Okay, you all should have answered this as 0, yeah, because see, I'll just explain you here. You all should have answered this question for 0, yeah. It's a very simple question, and this is a reality of what you call this NEET examination and all. See here, just now I taught you this concept. What is the formula for dv? Dv is always given as minus of E vector dot dr vector. So whenever v is, what is given to you here, v is constant throughout, so means what, dv is 0. If dv is 0, then what will happen? This part has to, therefore electric field will also be 0. If dv is electric field is 0, therefore the answer is what? This question is over. Right? This is what we have. So whenever your potential is constant, so what will happen? Your electric field also will always be 0. This is what you have. Because differential will be 0, so E dot dr is 0. E dot dr means what? E dr, some cos theta will be 0. So these things we don't know. Dr and cos theta is not known to us, but E definitely will be 0 from there, 100%. A very, very easy question. Give me the answer for this question. Again, a very, very easy question. Please solve it and give me the answer for the question. See, the diagram is not proper. I'll just write the values here. This is your 20 volt. This is an equipotent surface, 20 volt. The last is 40 volt. In every case, you have the same thing. 20 volt, 40 volt. Please, you all give the answer for this question. A very, very easy question. Trust me, it's a very, very easy question. See this question carefully and give me the answer for this question. You have some equipotential surfaces given to you, and then you're moving a charge from one point to another point. They're asking you what is the work done, and they're asking you to compare it. This is the question here. So answers we are getting here. Answers are like 2, 2. Okay. So most of you have given the answers to. So let's cross verify this answer here. See, just now I told you, in such cases we can always use which concept? Work done equals to what? Moving charge multiplied by V2 minus V1. So when you're moving the charge like this, right? You can see that V2 minus V1 is 40 minus 20 in all the cases. 40 minus 20, you have here, you have 10 here. I think it should be 20. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. No, it should be not 10, it should be 20 only. Okay. 10, sorry, 10, sorry, 10. 10 and 40. 10 and 40. So 10 and 40, yeah, correct. There you have 10 and 40. So the first and last is 40. So 30 volt is the, so Q into V2 minus V2. This is what, this is same. This is all same for all. So what is the answer? Answer will be 2. In all the 4 cases, the work done will be same. A very, very simple, a basic question. You just see the potential difference multiplied by charge. Potential difference for each movement is same. So when you multiply with charge, what will happen? Work done will come out to be same. Again, a very, very simple question. Tell me, within no time you should give the answer for this question. Fast, जल्दी करो सब कुछ. अभी तो पढ़ा. इसमें क्या करना है यार? आंसर देना है, जल्दी दो. Conducting sphere of radius capital R is given a charge Q. The electric potential and the field at the center of the sphere are respectively. सबको आंसर दो इसका यार. Okay, few answers are coming. Few answers are coming here. So B. Okay, so most of you are giving the answer as B. चलो अभी तो पढ़ा हम लोगों ने, जस्ट अभी हमने इसी को पढ़ा ना, हम लोग जस्ट अभी यही पढ़ा. So just now we have discussed this case also here. Okay, see now. Just now we have discussed if you have a spherical cell of radius capital R, right? You're giving a charge plus Q to it. Charge will distribute only on the outer surface. You know it very well, right? Will distribute only on the outer surface like this. So what will happen in this case? The electric field inside will be zero, and potential is throughout. Like I told you, what is surface potential? You will get a KQ by R. KQ by R. It will constant at the center also. What you will get the Vs value only. What is Vs? 1 by 4 pi epsilon naught. Capital Q by R. Electric field 0, V is constant. So everywhere, when not at the center, every point you will have this. So they have asked you first, they have asked you potential. So potential is what? KQ by capital, that is available. This is ruled out. And then electric field is 0. So this is also ruled out. And so option number B is the correct answer, right? A very, very basic and elementary question. Done? If you want, you can take the screenshot. We'll move to the next question now. Look, this screenshot. Okay. So let's see the next question. Okay, this is what you have. So now, okay, answer this first. Answer this question first. Fast. A, B, C are 3 points in a uniform electric field. The electric potential is same at all the 3 points. Maximum at A, maximum at B, maximum at C. Please answer this question fast. सब कुछ पढ़ा है, अभी जस्ट पढ़ा है, थोड़ी देर पहले पढ़ा है आप लोग. Okay, so we are getting the answers here. C. Okay, so all of you are giving C here. Yeah. Yes, you all are giving C here. Great. So let's see the solution for this question now. C. Yes, here. Just now we said that electric field always acts in direction of decreasing potential. No? So if the potential decreases, so this is always higher, this is always lower. And if you move the state, what will happen? Potential will remain constant. If you have to compare these things, what I'll do? First of all, I'll move all the things. I'll move A here perpendicular. I'm moving perpendicular, so I can keep A here also. I can keep C here also, right? So what is the order you will get? We'll get VB greater than VC greater than VA straight away. If they would have asked, they would have written an order also like this, right? Because we know that we can move perpendicular to it, right? At every point, potential will remain same. So if you're telling here VC, here also we'll have VC. Here you have VA, here also you'll have VA. So if you compare VB, VC, and VA, we will always have VB greater than VC greater than VA because this is what you have. So maximum we will have at this. Okay, it's clear to all of you. So maximum, this is the order that you will have. You want, you can take a screenshot. So all such questions, what you can do now, you can always bring all the points on a single line. Because how we can do that? Because we can always use the concept that if we move perpendicular to the electric field, what will happen? Potential will not change. If we have C here, they also will have C. If we have A here, they also will have A. Now, on a straight line, you can always apply this concept, and you can write the order also if you get such questions, right? Okay, let's see the next. Okay, this will enter into JEE main. Slightly, the level of questions will improve slightly. No, wait, we will not get very high-fi questions, but slightly the level will increase. Okay, so we'll discuss those questions. Before that, let's enjoy this question as well. Solve this question. Easy question. Please solve it fast. कोशिश करो एक बार, कोशिश करो सबको, फिर बताता हूँ मैं आप लोगों को. गिव अ ट्राई. ओके चलो मैं सॉल्व करता हूँ फिर देखूंगा आंसर आप लोग के लिए, ठीक है ना. लेट्स सी इट. इट्स अ वेरी वेरी सिंपल क्वेश्चन. देखो, V is given to you. They have asked you the electric force experienced by 2 coulomb charge situated at this point. At this point, first of all, we will try to find out the electric field. So, how will get the electric field from it? What is Ex component? Ex will be your minus of dou V by dou X. And what is Ey? Ey will be your minus of dou V by dou Y. And what is Ez? Ez will be your minus of dou V by dou Z. This is the formula that we have. So when differentiate with respect to x, keeping the other variables as constant. So straight away these two will give you 0, 0 because there's no variable there x. Right? So only these two will give you the component here. So 6 minus of 8y because x will dx by dx is 1, right? So 6 minus of 8y. What will get here? We'll get minus of 6 plus you will get what? Plus you will get sorry 6 minus dou v by dou x. So we will get here minus. This will give you 6. Second will give you minus of 8y, minus of 8y. So you got this value from here. Dou v by dou y. So all three will give you some term here, right? We'll get from here minus of, so first will give you 0. So first will give you 0. This will give you minus of 8x, minus of 8x. Then we'll get what? This will give you just minus of 8. And this will give you plus of 6z, plus of 6 into z. And this will give what? This will give you minus of, if we differentiate with respect to z, right? This is 0, this is 0. Only last term will give you value. All the other will give you 0 because all other will be constant. If there is no z in it, and last you will get 6y. So now at which point you have to find out? At 1, 1, 1. So what is the electric field expression you will get? Electric field expression at this point will be equals to what? This will be equals to, put this 1, 1. The 6 minus of 8, you will get minus of 2. Minus 2 into minus will become plus. You will get 2 I cap. This is I cap. No? Coming to this, you put 1, 1, 1. So what you will get here? Minus 8, you will get minus 16. Minus 16 plus 6. You will get minus 10. Minus 10 into minus plus 10. So you will plus 10j cap. And then here, if you put 1, you will get minus of 6k cap. You can take 2 common from it. So we'll get from it, you will get here 1 plus 5 plus 3. Sorry, I cap should write here. Sorry, this is a small mistake here. So I just write it here as what? I'll write this as, I'll take 2 common from it. We'll get, I'll get I cap plus 5j cap minus 3k cap. So what is the force? Force is always given as charge multiplied by electric field. What is charge here? 2. 2 into 4. 4 times of I cap plus 5j cap minus 3k cap. So what is the value of force? Mod of force. This 4 will be outside. Root of 1 plus, this will be what? 25 plus what? 9. Right? So we'll get here 29, 30, 35 will get. So we'll get 4 root 35 Newton. This is answer to the question. अक्षर अभी समझ में आया कैसे काम करते हैं?
Yes, sir.
That's what we have. तो यही आपका concept था यार, आप देख सकते हो. It is actually easy question. See, when you're differentiating this partially with respect to x, I just explained the first time again to all of you. See, when differentiating this with respect to x, what will happen? These two will not have, they don't have any x here. So these two will become constant. Straight away, these two will give you 0. Differentiate with respect to this will give you only 6. With respect to x, dx by dx is 1. So you will get minus of 8y. This is how I have written the first one. And similarly, I have written the other also. When you're differentiating, let's say 6yz partially with respect to x, this will treat as constant. So this will give you 0. This is how you solve the questions. A very, very easy question. You can see how easily you can solve these questions. Okay, let's see the next question now. So we enjoyed solving all the baby sums here. Okay, this is the meaning of Neet, NAI, PMT. And for this Akash and Ellen keep showing what you call a very difficult world to the students to get that 1 lakh, 2 lakhs from the student. Okay, this you can see the questions are so simple, so easy. यार कितना आसान होता है देखो आप. I'm not trying to what you call define the value of what you call these institutes, but actually they're not showing the correct picture to the students. तो कितना आसान होता है, सारे क्वेश्चन आसान होते हैं. I will come to this by the way. So wait for a moment because dipole I will consider a special case. Okay, so let's start now solving some standard questions of JEE. Okay, let's solve this question. You can take all the NEET questions as your board questions. Sir. They can ask you these questions in CBSE, ISC boards. NEET means board paper only. Anyone getting the answer for this question yet? तो किसी ने आंसर देना शुरू किया चलो so we have got an answer here A. Okay. चलो देखते हैं इस क्वेश्चन को यार Okay, I'll solve this question for all of you. It's not difficult, please hear it. It's a very basic and elementary question. Okay. A. Okay, Anjali is also giving the answer as A. Okay, please hear it. Let's see how we get the answer for this question. First of all, what is given to here? A system of charge. This Q is uniformly distributed over this rod. And for this rod, there is asking you what is the potential at O. What is the potential at O? So what you can do here, see, you have to calculate the potential due to all the charges. We don't know for a rod. First of all, charge is spread over a length, na? So lambda. Lambda is what you can write total charge by total length. Lambda is the charge per unit length. So now what you can do here, you can take any charge from the system, let's say at distance of x. You will go at a distance of x and you will take a small charge here dx. This is your dx. In this dx, you will have dq. What is the value of dq? Dq can write as what? Dx. Dx is like very, very small, right? So dq will be what? Lambda into dx. Lambda is charge per unit length. So multiply by the length. So what is dq? Dq can write as this dq will be equals to what? Lambda into dx. Means what we'll get here? Q by L into dx. You got the value of dq. Now this dq will create a potential at O. What is the formula for that? Therefore dv, you will let dv equals to what? dv will let as what? kq by r. So 1 by 4 pi epsilon naught. Q. What is q here? Q is this. Q by L into dx. By what? By x you will have here. This will have here. So now total potential will be what? Total potential will be this q by 4 pi epsilon naught into L will be outside constant. You will integrate dx by x. From where to where? From dx by x, from where to where you will integrate this? You will integrate from lower limit is what? You can see lower limit is L. From here to lower limit is what? L. And upper limit will be 2L. So from L to 2L, we'll get here. Q by 4 pi epsilon naught into L. What is 1 by x integration? Is ln x. From where to where? From L to 2L. So upper limit minus lower limit, we'll get here. Q by 4 pi epsilon naught into L. We'll get ln 2 minus of ln L. So ln A by B, so we'll get Q by 4 pi epsilon naught into L into what? Ln 2L by L. L will cancel. What is the answer? Q into ln 2 by what? 4 pi epsilon naught into L. This is what you have. This is available here. Such an easy question of this category here, potential. You know, for a point charge, what is a point charge potential? KQ by R, KQ by R. So what we do here, we divide this entire rod into small charges, dq, 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 like this. And with references to this O, we set a coordinate frame, let's say like this, x-axis like this. Okay, and then we frame here this we can keep aram as x. This will be what? This will be 12. So we move at any x, we take a small length dx. For dx, I can find the value of dq. dq will lambda into dx. And for this dq, we'll calculate the potential at O. What is the formula? This is the formula. Kq by r. K is one. Q is this q by n into what? What is r here? Kq by r x. So now we integrate this dv from where to where? From this end to this end. So this end, what is the value of x? We have L. And what is the value of L at the end? 2L. So from L to 2L, integrate this, and then we'll get the answer for the question. A very, very elementary question. This is the oral layer. Tell me the answer for this question. Oral question. इस सबका आंसर तो जल्दी से इसका. अरे ये ओरल है भाई, इसमें सॉल्व क्या करना है? क्या तमाशा बना रहे हो? जल्दी बता इसका आंसर. कुछ आंसर्स आ रहा है यार. We're getting some answers here. 2. Okay. 2. चलो ठीक है. कुछ लोगों ने 2 बोला है. ऐसा सबको बोलना चाहिए, इसमें कुछ भी नहीं है यार. ओके चलो देखता हूँ. See, again I'll tell you what current I won't teach you all in detail. I'll go to the actual level of JE also for that chapter. The reason is very simple. Then only we'll get the correct what do you call confidence here in current. Because there's so many topics which are not, there's so many concepts which they have not covered in NCR textbook here. So I'll teach current in detail. It may take 1 week's time, but trust me, after 1 week's time, we will master current like anything. 1 week लगेगा, लेकिन 1 week के बाद you will definitely enjoy current. See, you know these concepts, right? See here. You know these concepts. Whenever you have a dipole here, minus q and plus q, this is your, it is 2a. This is your dipole axis. Let's say we write here x cap. I guess with the question x cap is written this unit vector along this line, axial line. So if I give you any distance r here, or let's say d here, d is very, very large as compared to a for a far point, right? So for this, what is p vector? P vector is given as q multiplied 2a and direction is along x cap. So how we write the potential here? Potential at this point is written as, sorry, the electric field at this point is written as, E vector is written as 2 times of k into p by dq, where along x cap. And if we say take the same distance d here on the equatorial line, electric field will be this side, and the electric field E value is given as what? Electric field E value is given as kp upon d cube. We have derived these things here along minus of x cap. We should not have any confusion regarding this. I know that just now I explained while listening theory. This is always an equatorial line. This is always an equatorial line. Equipotential line, I will say. Equatorial line is always equipotential line. This concept always keep in mind. Therefore, you can see that this is your E axial, this is equatorial. So you can see E axial, equatorial. You can see that if I divide the mod of E axial by E equatorial, I'll get the answer is what? 2:1. 2:1. These many concepts should always be there in your mind. ये आपको हमेशा याद होना चाहिए. ठीक है? So now we'll solve the question. They're asking potential electric field on the y-axis, and they have given the dipole along the x-axis, right? So what will happen at a distance d, right? Is kept at the origin. Okay, this is see what is the meaning of kept at the origin or at the origin? What is the meaning of this language? It basically means 2a tends to 0, 2a tends to 0, and therefore what will happen? This dipole is just a point for you. What is the meaning of the statement here? This statement means what? This basically means you are treating dipole as a point, And why you can treat dipole as a point? Because this 2a is what? Infinitesimally small. So you can say the dipole is kept at the origin. That's the meaning of this. How you can keep a dipole at the origin? How it is possible? It is possible because 2a tends to 0. And then if you move and the dipole is along the x-axis. This is what you have. This is what, though it's very, very small, but it's along the x-axis. And then you're moving perpendicular. It means what? They are talking about this line, approximately this line. So for this line, just now we have seen what will happen. Potential will be 0, and your electric field will be what? Minus of kp by. So this is answer number 2. It's a theory. It's a question based on theory. That's it. If you want, you can take the screenshot. So this much information you should always revise regarding a dipole. 2-3 points और है वो मैं डिस्कस करता हूँ तुमसे. You can take the screenshot. ये पॉइंट्स तुम्हें पता होना चाहिए. क्या क्या देखो मैं क्लाउड बनाता हूँ. I will just put a cloud here. This concept first, second this, third this, and fourth this equipotential line, and this so you can relate. ये सारे पॉइंट आपको अच्छे से क्लियर होना चाहिए अंडर दिस. एक स्क्रीनशॉट ले लो. ठीक है ना? ये तो आपको अच्छे से याद होना चाहिए. What extra you should know about dipole? Standard बोल रहा हूँ मैं. Standard cases. Okay. So let's see some other standard cases that you should know about dipole. उसको देखते हैं. Let's see. चलो इसको सॉल्व करो. See, other cases you have is this thing. Whenever you keep a dipole, let's say you have electric field E vector, and you keep the dipole like this, P vector. When I write P vector means what? Your charge minus Q is here, and your plus Q is here. That's the meaning of dipole at an angle theta. In this configuration, what torque we write? Torque vector is given as P vector cross E vector. And what is the U? Potential energy U at theta is given as what? Minus of P vector dot E vector. And these two concepts you should always keep in mind here. Okay, this is what you have. Now solve this question. You have an electric field and have kept the dipole at an angle theta with the electric field. So you have two expressions for torque and for energy. Torque is always P cross E, energy is always minus of P dot E. Sorry. Okay, some answers are coming here. So I will see the answers. 2. Okay. So if you have given answer 2. So please say that. What is U at theta formula? U at theta is given as minus of P cos theta. So when you rotate the dipole from theta 1 to theta 2, let's say. So what is the change in energy? Change in energy will be your U at theta 2 minus of U at theta 1. So what you will get here minus of PE cos theta 2, then minus of minus PE cos theta 1. Because you will get PE cos of theta 1 minus of cos of theta 2. This will get. What is delta D? Delta U itself is what? Work done by agent, no? Work done by external agent. This is what you have here. So in this case, energy required means what? Work done. Whatever work that is energy, no? You need to supply energy. This is work done by agent. What does it mean? Energy required is basically energy work done by agent. Energy required is always work done by agent. Dipole, to rotate the dipole by 90 degrees. First of all, it is given parallel. Means what? Initial theta 1 is what? 0 degree, and theta 2 is what? 90 degree. This is the meaning, no? Put the things here. Theta 1 is what? 0 degree, and theta 2 is what? 90 degree. Cos 90 is 0, so we'll get P. So P is the answer for the question. Right? A very famous question in your board papers here. They ask you to rotate a dipole from where to where? Stable equilibrium, stable to unstable equilibrium. Either this way or they can ask you this way. This way means what? It is basically 0 degree. It is basically what? 180 degree. If you move this way means what? Theta 1 is what? Theta 1 is theta 0 degree and theta 2 is what? Theta 2 is 180 degree. And if you move this way means theta 1 is what? 180 degree and theta 2 is what? 0 degree. Right? And you can just use this expression. If you want, you can take the screenshot. ये भी काफी स्टैंडर्ड है, हमेशा आपको याद होना चाहिए. ठीक है? Fast take the screenshot for this. Okay. Now let's see the next question. A second now. Yeah. So जल्दी बताओ इसका आंसर. An electric field of 1000 volt per meter is applied to an electric dipole at an angle of 45 degree. The value of electric dipole moment is 10 to the power minus 29 coulomb meter. What is the potential energy of the electric dipole? This is the question. कुछ आंसर आ रहा है यार. बी. चलो सब लोग सॉल्व करो इस पर. It's an easy question. You all can give the answer for this question. सबको बताओ इसका आंसर में क्या है, जल्दी बताओ. Okay. चलो बहुत लोगों ने इसका आंसर भी दिया अभी तक. अदर्स प्लीज ट्राई, सबको ट्राई करो, आसान क्वेश्चन है. You all can give the answer for this question. Yeah? There's nothing in this question. What is the energy formula? Just now I told all of you, right? It is just U at theta is just minus of P dot E. अब क्या चाहिए तुम्हें भाई इसमें? देखो, minus of P cos theta you will let like this. P value भी दिया हुआ है 10 to the power minus 29. E value भी दिया हुआ है 10 to the power of 3. And cos 45 degree होता है 1 by root 2. 1 by root 2 is 0.707 होता है. You know this, you have seen in current also. तो हो गया ना. If you club these two, it is what? 29. It will become 29, 26. It will become 26. So minus of 0.707 10 to the power of minus 26. So if I want to write in 7.7 now, so you have to multiply by 10 and multiply by 10 and divide by 10. This 10 we can multiply, so we'll get minus of 7.07 into what? 10 to the power minus 27 joules. तो ये कितना बेसिक है यार, बेसिक क्वेश्चन. ये सबका आंसर आना था इसमें कुछ भी नहीं था. कितने लोगों ने दिया इसका आंसर? सबको देना चाहिए, तो सबको बनाना चाहिए इधर. बहुत लोगों ने इसका आंसर दिया, सबको देना था इसमें कुछ भी नहीं था. इसमें वेरी इजी क्वेश्चन. ओके. चलो इसको सॉल्व करो, प्लीज सॉल्व दिस क्वेश्चन. Now, why I have taken this question here? The reason is very simple here, because most of you will miss out the first formula that is derived in NCERT textbook here. Whenever you have potential here minus Q and here you have plus Q, this is the origin. So if I ask you the potential at distance of R from here at an angle theta, so we have derived the formula for this here, potential at P. What is the formula for V? It is given as 1 by 4 pi, that is K, P cos theta upon R square. We have derived this formula in NCERT. जाके बुक देखना, पहला डेरिवेशन नहीं है, इसको नहीं भूलना है. अब तो क्वेश्चन में कुछ दम ही नहीं है, एवरीथिंग इज गिवन टू यू. 1 by 4 pi epsilon naught value is also given to you. What do you want? 9 10 to the power of 9, और इधर p cos theta. p क्या दिया हो तुम्हें इधर? 16 into 10 to the power of minus 9 into cos theta. Cos theta कितना दिया इधर? 60. Cos 60 is half by r square, 0.6 meter. So 0.6 into 0.6. You have to solve this. ठीक है, सॉल्व कर सकते, कोई बड़ी बात नहीं. They'll give you 8. So we'll get here 9 by 36. You can write 100 here, 10 to the power 2, and then you will have here 8, and then you will have 10 to the power. This will get cancelled only. This will give you 4. This will give you 2, 200. Right? 200 volts. तो आप इतने आराम सॉल्व कर सकते हो, प्रोवाइड यू नो द फॉर्मूला. आपको सबको फॉर्मूला आना चाहिए. कितने लोगों ने सॉल्व किया इसको? Okay, CC. Okay. Just this question I have taken just to remind you that you should not miss out this formula here. It's the expression for potential in terms of theta. You can see here. From here also you can see that if theta is 90, from here also you can see that if theta is 90, what will happen? Your V will come out to be 0. वही तो पढ़ रहा था हम लोग अभी ना. अभी थीटा को 90 कर दो तो क्या हो जाएगा? V अपने आप तुम्हारा क्या हो जाएगा? 0 हो जाएगा. देखो यहाँ से हो जाता है. Same result. Right? See here. So you can see if you rotate from here to here, dipole, what will happen? Your potential will first cos 0 degree. You know this cos graph, na? You just see the cos graph. It goes like this. So potential will be maximum here. It will continuously decrease and drop to 0 here, and then from here to here it will become negative. And then again like this. This is how the potential variation will take place if we rotate this dipole. No, it's a cos graph. Okay, so we have covered all these questions here. 1, 2, 3, 4, 5, 6. Everything is over. Now we are left with the last 3 questions, sir. This question, this, and then this. It's a beautiful question. Hai? This I will do at the end. Okay. And these are easy questions. Let's start solving this question. Yeah. Okay, these questions. Okay. This and this both are like same only. Yeah. Okay. So. Okay. Solve this question. Solve this question. Hello. Class किसी का आंसर नहीं लगता है. सबको इसका आंसर लाओ यार. बहुत ही आसान क्वेश्चन है, तो बहुत बेसिक क्वेश्चन है, बच्चों वाला क्वेश्चन है. कितने लोगों ने आंसर दिया? से कुछ लोग आंसर दे रहे हैं इसका. बी. सबको दो इसका आंसर. इसमें क्या है? इसमें जेई है, जेई लिख दिया बस. क्या जेई इसमें? You have 3. Ajay बताया. You will have 3 pairs, right? Calculate all the charge. It is given as what? A right angle isosceles triangle means what? If you take this as A, This is a, this will be what? Root 2a, right? यदि a लोगे तो root t हो जाएगा. तो सबके लिए पोटेंशियल निकाल लो, कितना हो जाएगा? For this pair you will get what? kq square by a. For this pair you will get what? You will get here k capital Q into small q by what? Again a. And for this pair you will get what? K into capital Q into small q divided by root 2a equals to what? 0. So now you can cancel the things from it. A can be cancelled. K can be cancelled. 1q can be cancelled. So what are you left with now? You are left with q plus capital Q plus q by root 2 equals to what will have 0. What you have to find? You have to find the value of capital Q. So what is capital Q? You will get a q equals to what? Minus of q 1 plus 1 by root 2. They're asking capital Q. So what is capital Q then? Minus of q. We'll get here. Root 2 will come down and then root 2 will come up. ऊपर चला जाएगा root 2. And then here you will have root 2 plus 1. It's a basic question. It's a basic question. Calculate total energy and equate to 0 and then you get the answer for the question. That's it. Over. चलो अब 2 क्वेश्चन और बस. चलो ये भी आसान है. चलो सॉल्व करो इसको. This is also a very easy question. Solve it. Four point charges, capital Q each, are placed in the XY plane. Coordinates are given to you. Work required to put a fifth charge Q at the origin of the coordinate system. उसका आंसर बता रहे. ओके, 2 लोगों ने बी बोला. ओके, चलो 3 लोगों ने बी बोला. Okay, so hope now you can understand the importance of theory in physics here. If you know the theory, you can solve the questions really fast. I am again requesting to all of you, please make your own notes. You can always make help. You can always take help from what I'm teaching to all of you and prepare notes. It'll help you like anything before the exam. So what is given to you here? You have XY plane here. You have a XY plane here. You have a XY plane here. You have XY plane here. So see here. Okay, so you have an XY plane. So let's say like this here. XY. So your points 0, 2, 1, 2. This is your 0, this point is your 0. Oh, sorry, this point is your y axis. Sorry. This is your 0, 2. One point. Then 4, 2. 3, 4. 4, this is your 4, 2. 4, 1, 2, 3, 4. 1, 2, 3, 4. 4, there. We have 4, 2. Then you have 0, minus 2. 1, 2. 0, minus 2. Here. And then that's it now. And then you have one more. 4, minus 2. 4, here. So basically you have a rectangle here. You have a rectangle. You have a rectangle here. Rectangle or square. This will be 4 and this is also 4. It's a square basically. You have a square here. The question is work done to put a fifth charge Q at the origin of the coordinate. So you have to bring a charge Q from infinity to this origin. They ask you what is the work done. So what we can do, we are moving a single charge in a given system of charge. So what we can do, what we can see here, potential at infinity is what? 0. We will calculate the potential here. These two are at 2 and 2, and these two are what? If you see for these two, the distance will be what? This is 4. This is your 2. This will be root of 16 plus 2. 16 plus 4, sorry. So we will get 20. Means what? 4 into 5, 2 root 5. We will get here 2 root 5. due to these two potential will be what? You will write it 2 times of q into k, obviously kq 2 times by what? R. What is R here? 2. Q by R, correct. And plus 2 times again what? K into q by what? What is R here? 2 root 5. So 2 can be cancelled, 2 can be cancelled. So if we take the thing common, what will get here? A kq common, so we'll get 1 plus root 5 here. And just multiply by q. So what is the answer? 1 by 4 pi epsilon naught you have here. So you'll get q square, 1 plus 1 by root 5, which is the answer of the question. That's it, over. This is what I discussed with all of you in the theory. Whenever you're moving a single charge, right, you just use the formula. What is the formula? Q moving multiplied by V final minus V initial will give you the work done. V initial is 0, V final you can calculate, take the difference, multiply charge, you get the answer for the question. That's it. Okay, let's solve this question. Last two questions here. In free space, a particle capital A of charge 1 microcoulomb is held at a point P. Another particle B of same charge and mass 4 microgram is kept at distance 1 mm from P. If B is released, then its velocity at distance of 9 mm is. This is the question. So what is the question here? You have a charge capital A of 1 microcoulomb. It is fixed. It is what? This is fixed. This is not moving. It's fixed. It's given the question. It's fixed. Another charge capital B of same charge a charge of same charge is 1 microcoulomb only and mass 4 microgram is kept at distance of 1 mm. Initial distance between them is what? 1 mm. This is your B, and it moves from here to another location. Let's say B here, 9 mm. B here U was 0, and here it's acquired some velocity V. They're asking you what is the value of V. See, we can calculate the work done now by the electric field. Work done equals change in kinetic energy. Work done equals change in kinetic energy. Work done is what? You can calculate the potential at this point difference multiplied with the q that you are moving. So kq by r. So kq is what? 1 microcoulomb. So 1 10 to the power minus 6 kq by r. What is the final r? 1 by 9 millimeter. Millimeter 10 to the power minus 3 I will write here. Minus what? 1 by 1 10 to the power minus 3. This is what we'll get here. Change kinetic energy, final initially 0, so half mv square. M is given to you in the question as what? 4 microgram. So 4 into 10 to the power minus 6 into what? V square. Now we have to solve this expression. What is k here, by the way? K is your 9 10 to the power 9. 9 into 10 to the power 9. What is k here? 9 10 to the power of 9. So what you can do, we can cancel this 9 9. There's no 9, sorry here. We have 9 here, but there's no 9 here. Okay. Then we can multiply inside. Okay, so what we can do here, we can take this 9 10 to the power of 9. If you multiply this, you'll get 10 to the power of 3. And in these two, I can take 9 into 10 to the power minus 3 as a LCM. What will get here? I'll get here. I'm getting negative. Final minus initial, change in kinetic energy. Final minus initial. It is moved from 1 mm at distance of 9 mm. I'm getting negative here. क्यों नेगेटिव हो रहा है भाई ये? के क्यू बाई आर, ठीक है, के क्यू बाई आर। Charge is moving, a single charge is moving, but then it's not moving in quasi-static motion ना, so वो concept नहीं लगा सकते हैं, कोई दिक्कत नहीं इसमें, you can use that concept. Q square initial is 0, क्यों गलत आ रहा है यार? Their work is done by electric field, na? Electric field, right? So electric field work done is what negative of this, na? Because this, are you understand? I'm taking here work done by all the forces. Who is doing the work here? Electric field is not the agent. The charge is moving due to the electric forces. It's work done by electric field. So we have to take a minus sign here. So automatically this minus will convert this. So I will have here what? 1 minus of 9. Will become plus and then 1 by 2. So this is just 2. 2 and 10 to the power of minus 6 v square. Now it's correct. So from here we can solve now. Here. This 9 we can cancel. This minus will multiply, will get plus 8, 8, and then you have 10 to the power minus 6 here, 10 to the power minus 6 here you have, and 2 and 10 to the power minus 6 you have here also into v square. So 10 to minus 6 will cancel. This is 4. Root is what? 2. So 2 आ रहा है यार. आंसर में 2 दिया ही नहीं. क्या गलत हो गया भैया? 8 है, 8 will give 4 root. क्या गलत हो रहा है यहाँ पे? 10 to the power 3 भी है. टेन टू द पावर ऑफ, ओ सॉरी 6 तो 6 है ना, v स्क्वायर है, सॉरी, ओहो सॉरी, एक मिनट है, v स्क्वायर है ना, सी, एंड इट इज स्मॉल मिस्टेक, दिस नॉट गेट कैंसिल, सी हियर, sorry, so here you will get what, here you have 10 to the power 3 and here 10 to the minus 3, so it will become 10 to the 6, 10 to the 6 you will get here, this will become what, this will become 8, because to what you have, here you have 2 into 10 to the power of minus 6 into v square you have there. This will become 4, it will become 12. So you will get v equals to what? You will get v equals to under root 2 into 10 to the power of 6 you will get. This will be 1.414, 1.41 10 to the power 6. Actually, bonus question था, कोई भी ऑप्शन सही नहीं इसका. It's a bonus question it is asked. This is how you will get the answer. It's very very important to understand that if I use this work energy theorem, na, here work is done by the electric force. So when I am applying this, what I have done here, I am calculating changing potential multiplied by charge. But then I have to, or other way of solving this question. By the way, I always suggest to keep this concept in mind. In the question, in this question, you are getting work done by electric field, not by the agent. So how we calculate? You calculate changing electric potential multiply charge. But this we have to multiply with minus because we are calculating work done due to electric. That will be negative, right? Another way of solving the same question can be like this. See. We can apply conservation of energy. So what is the initial energy you have? Initial energy and final energy will be same. Initial energy and final energy will be same. So initial energy, when you write here, you will get what? Initial energy equals to final energy. Initial energy you will have Uy plus kinetic energy equals to what? Uf plus kinetic energy, right? Ki already 0 given the question. And what is this? This will be your K. Same thing. Q square you will have because Q and Q are same. By what? 1 millimeter you will have 10 to the power minus 3. And final what will have? Q square by what? Again 9 and 10 to the power minus 3 plus what? Half mv square. So from here also you can get the value. This way also you can solve the question. Right? Okay, take a screenshot here fast. So now the last question. We'll discuss the last question for today. A good question. Not difficult, but a good question. See what you have here, a uniformly charged ring of radius 3a. So you have a ring. The radius is given as what? 3a. It's uniformly charged. It's placed on the xy plane. You have x-axis here, and here you have y-axis. Okay. A uniformly charge ring and charge q. Okay, charge is given as q. Means what? You have in this, how much charge you have there? Q. This is, q is uniformly spread over the circumference like this. This total charge is what? This total charge is given as plus q. A point charge q is moving towards the ring along z-axis. Okay, so you have a z-axis. They are talking about z-axis here. So the z-axis is coming out of the plane. It's like this. Okay, so it's moving along z-axis, has a speed, is moving towards the ring. Okay, so it's moving towards the ring and has speed v at z equals to 4a. Okay, so let's say from the ring it is at a distance of 4a initially. It is moving with the potential, it is moving with the velocity speed v. Now you can see that this charge is plus q now, the same charge. So this ring will have electric field here, right? And the electric field will continuously retard this, will try to repel this, right? I'm telling you what is the minimum velocity v, so that it will just reach the center of the circular ring here. Charged ring. This is a question. See again, I'll repeat here. You have a ring, charged ring here. You have xy plane here. This ring is kept over this xy plane. Charge is q. This radius is 3a. Now on the z-axis, you're taking a charge here. This charge is moving towards the ring with a speed v. So obviously this is a positive charge. So the electric field due to this will continuously repel this charge, and the velocity will decrease. They're asking you what is the minimum velocity v, so that it should reach the center of the ring. This is the question. Now again, a single charge is moving from here to here. And, or you can say like this. See, again, I can apply work energy theorem. What is work energy theorem? But again, you should not do the same mistake what I did in the last question. If I am applying work energy theorem, work done by electric force, not an external agent, equals to what? Change in kinetic energy you have here. Change in kinetic energy. Final kinetic energy 0. Initial is what? Half m v square you will have here. And what is work done by this? The moving charge q, you will have minus here. Final potential here. You can apply this same concept on all charges at distance of 3a. So right, so what will let final potential? K into q by 3a you will let minus of initial potential. Again, it is at the same distance now from the circumference. What is this value? This is your 3a, and this is your 4a. If you take the root, you will get here what? 16. This is 9. So you will get a 5a. You will get 5a. So what is the initial potential of this ring at this point? Initial potential will be what? Kq by 5a. This will get. So now we have to solve this. So we'll take this kq outside. We'll take this kq outside by a also outside. We'll k into kq square will become. We'll get here 1 by 5 minus 1 by 3. We'll get like this. Equals to what? Okay, this minus you should not multiply here, because we can cancel this minus here. So what I'll do here, I'll just write this as 1 by 3 minus 1 by 5. So I'll get here 1 by 3 minus 1 by 5. And here we will have, acha, q is k is not q as a, sorry, this is a, no? This is your a. Equals to what you have here, half m v square. So what we can do, we can cross multiply. So we'll get here, we will get here 2, and this m will come outside, 2 by m. This entire thing is what? If you see here, 2 by 15 you will get, 2 by 15. I can write here 2 by 15 into 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, and then q square. V square is there now, so to the power of half. So we'll get root here. This is how they have written the answer here. So I'm writing the same form, half. This will be the value of v in the question. You can see which option is matching here. Root 2 by m, 2 by 15, q square, half. I think this option is matching here, right? और कोई ऑप्शन मैच कर रहा है क्या? ये सेम लग रहा है, ये तो गलत हो जाएगा. A is also there, no? So A to my miss कर गया. A should also be there. So 4 pi epsilon into A. 250. This is what you have. Yes. Again, I'll repeat this question. See the solution for this question again. See. You can take a screenshot if you want. See. In this case, what you have here? A charge is moving from this point to the center. The charge is moving from one point to another point. And here initially you have some velocity. In the previous question, in the previous question, if you see here, in this question, your initial velocity was 0 and final velocity is something. But in this question, you have initial velocity something, but the final velocity is 0. The charge moves from here to here, but it will move due to the work done by the electric force, right? So we'll calculate the work done by electric force. That will be negative if we use the concept of potential, right? Because we know this is delta V. What we know the concept? See, we know this concept. Delta V is what? Delta V is your minus of work done by electric force divided by Q. Now, so Q and delta V can multiply and with a minus sign. Then only you'll get the work done by electric force. So Q into change in potential. At the center of the ring, all the charges at equidistance, right? So KQ net by R formula I can apply. So KQ net is this, R is what 3A. And at the actual point, I told you KQ by, so final minus initial you can do. The charge that you have moved is Q with a minus sign equals to what? Half mv square. Final 0, initial is this. So you can solve it, you'll get the answer for the question. That simple as this. Okay. Okay, chalo, we'll end the class for today. Do revise this sheet of capacitor and this completes everything electrostatics. Again, I request all of you, if you get doubt on Monday, you can come earlier, let's say 2:30 only you can come and you can ask me doubts from this electrostatic sheets here. Okay. I'm starting the class at 3 o'clock, but if you have doubt from the sheets, you can always come half an hour before and you can ask me doubts from this electrostatic sheet and this electric field. Okay, chalo, we will end the class.